time value of money topic. And last class we talked about the future value, present value, and how to calculate those things, okay, using the table and the calculator. Okay. All right. Today we're going to start out with the concept called annuity. Annuity is a series of equal cash flow amounts, and the cash flows occur for a finite number of periods. That's another condition. Okay? And cash flows occur at the same point in each period. Okay? So what we're talking about is when we have timeline, as we've discussed last class on Tuesday. Let's say we have n period. Okay? And last class we just talked about single cash flow at the end of certain period and how to discount that to the present value, okay? Or if you invest certain amount, by the end of nth period, how much that will be, right? That was the concept of future value and present value, okay? The annuity, we're talking about repeating cash flows, okay? Somehow you receive this money, cash flow every period. Okay? Okay? And again, the first condition here is equal amount of cash flow. Okay? So every time you receive the same amount. And then we have to have finite period. We have to know how many periods we're going to receive, or it could be cash inflow, it could be cash outflow. Okay? But we have to have certain end, okay? How many periods. And then another thing is we have to know whether it occurs in the beginning of the period or at the end of the period. So if you receive the money at the end of first period, then in order to qualify as an annuity, you have to receive the same amount of cash flow at the end of every period, starting from the first period. Okay? Or if you receive the cash flow in the beginning, or if you invested in the beginning of the first period, and from then on you have to have the cash flow in the beginning of every period. Okay? That's what this means. Cash flows occur at the same point in each period. All right, so if cash flows occur at the end of each period, that's what we call ordinary annuity. Okay? If cash flows occur at beginning of each period, we call it annuity due. Two different concepts. Very similar concept. The only difference is whether the cash flow occurs at the beginning or end. Okay? Well, as we go on, we'll talk about it in further detail. All right. So here's a formula for future value of an annuity, ordinary annuity. Okay? So here's a timeline illustrating this ordinary annuity. Okay? We have 3-year or 3-period annuity here. Okay? And apparently, well, it doesn't say whether it's a cash inflow or outflow. It doesn't matter. Okay? But there is $1,000 payment. Payment is the amount of cash flow at each period. Okay? So at the end of first year, there's $1,000 cash flow. At the end of second year, another $1,000. At the end of third year, another cash flow of $1,000. And we're trying to find out the future value. How much will it be? So, example, can you think of any examples of annuity? Based on what we talked about so far, right? We're talking about series of equal payments, right? Whether you receive it or you pay it, doesn't matter, okay? But we're talking about repeating cash payments over the years, over many periods. What can be a good example? What did you say? Pension, okay, your retirement fund, okay. So when you are young, when you work, right, typically every month when you get paid your salary, okay, the company would take away small amount, a small portion of your paycheck, right, and deposit into the pension system, okay. So that will be a cash outflow, okay, in that case. At the end of every period, every month, okay, you deposit small amount of money into your pension fund, okay? So that's a cash outflow because it's coming out of your pocket, okay? You're investing, yeah? And so, after so many years, so many months, okay, by the time you retire, how much will it be? What will be the value of your total retirement fund, okay? Yeah, that's a good example of an annuity. Any other example? I'm sorry, what? 적금? Okay. Yeah, okay. I guess I don't know what it can be called. I guess installment saving, okay. That's good translation. Yeah, installment saving, okay. So you are putting certain amount of money, equal amount of money, okay, every period into your savings account, okay. And yeah, so by the time you withdraw, or maybe there is a maturity, okay, certain set period, number of periods, and at that time you can withdraw the whole amount, okay. All right. Another example is loan. When you get a loan, okay, when you buy a car, let's say, you borrowed money, and say that was a 48-month loan, okay. Then every month, it's a slightly different case, okay. So initially you borrow large amount of money, okay. Here's a large cash flow, okay, and then you are paying back every month, okay. So let's say 48 months. By the end of 48 months, the entire amount that you borrowed plus interest would be paid for, okay. So that's another example of annuity, okay. You can think about many different examples. Mortgage, if you borrowed money to buy a house, okay, then again you borrowed a large amount. So initially there's a large amount of cash inflow, okay, but then there will be repeating amount of cash outflow for the next 15 years or 30 years, okay, and so on. That's the idea of mortgage, okay? Yeah. So that's a good example of annuity, okay? Now, so here's an illustration, simplified illustration. We have 3-period annuity, okay? And you make a deposit of 1,000 here and 1,000 here, and at the end of third period you make another deposit of 1,000. What will be the total value? Okay. Well, you can calculate the future value of this initial deposit, okay, because that's going to earn interest for 2 years. Okay. So we're talking about compound interest for 2 years. Okay. So you can use from the FVIF table, I believe it was table number 1. You can find the FVIF future value of interest factor, FVIF, for 6% for 2 years. Apparently it was 1.124. So $1,000 earning 6% interest compounded for 2 years. That value is 1,124. And here, the second payment of 1,000 earns interest for only 1 year, okay? For 6% interest for 1 year, right? So that's obviously $1,060. The last payment does not earn any interest because as soon as you make the deposit, That's the end of the annuity you withdraw, right? So when you add them up, the total value comes out to be $3,184. Okay? Well, you can calculate it this way, or you can use FVIFA table. That's table number 3. Okay? So if you open table number 3 at the end of your textbook, that's a similar table as you've seen before. What page is it? Table number 3 is on, well, page number T4. Okay? So it looks just like FVIF or PVIF table. Okay? So across the table, they have listed all the interest rates. Down the first column, there are a number of periods. Okay? So if you look for 6%, 3 years, what do you get? What number do you see? 3.184, right? That's exactly what we see here, right? $3,184, okay? So in case you're dealing with annuity, you can use table 3 to calculate the future value of annuity, okay? FVIFA or FVAN, future value of annuity. You multiply PMT, which is 1,000 here, right? Times FVIFA for corresponding interest rate and number of periods. Okay? Simple. Okay. All right. Now, our textbook does not explain how this formula, this FVIFA formula has been obtained, right? But, well, I'm sure many of you are wondering how that formula has been obtained. So I have copied this material from some other textbook. Okay? And let me just briefly try to explain how the formula has been obtained. Okay? In order to understand that formula, you have to first understand the concept of perpetuity. Okay? This is actually the topic of chapter 6 when we deal with bond. Perpetuity is a bond which makes interest payments forever. Typical bonds make interest payments for every period, usually every 6 months, for 10 years or 20 years. Excuse me. And after the maturity of the bond, whether it's 10 years or 20 years, it pays the interest payments and the principal. And that's the end. That's the end of the life of a bond. Right? But perpetuity, there is no end. There is no maturity. They just pay the interest payment. Usually it's called the coupon payment. Okay. Interest payment on bond is called the coupon. Okay. And it just pays forever instead of paying back the principal. Okay. It's a special type of bond. It's very unusual. It is very rare. Okay. British consul. It's a bond issued by British government. Okay? It's called the consul, okay? And that's a perpetuity. Okay? And the ordinary private companies, private businesses will not issue consuls or perpetuities. Think about it. I mean, if you lend money to a company and company says, we're not going to pay it back, we're going to just pay the interest forever. Right? Can you trust it? Right? The companies may have limited life. Okay? So at the end of, after certain years, 20 years, 30 years, company may go bankrupt or company may not exist at all. Okay? So in order to issue the perpetuity, you have to have really good credit. Eh? Something like government, U.S. government or British government. Eh? Well, even those governments these days do not have very good credit. All right? So that's a very typical, atypical, very unusual situation, right? But let's say you have a perpetuity, okay? Then we're talking about this cash payments, cash flow every period, okay? So what's the present value of this perpetuity? In other words, if someone offers the perpetuity, how much would you or should you be willing to pay, right? If someone say, hey, I'm going to pay you $10 every 6 months, forever, right? Then how much should you be willing to lend for this person or this company, right? So in order to make that decision, you have to discount all these cash flows, right? And that's what this is about. Yeah? Present value of the annuity is coupon payment divided by 1 plus R. So that's the first payment discounted to 1 year, for 1 year, to present value. And this is the same amount of money discounted for 2 years, 3 years, and so on. Okay? So imagine this equation going forever. Okay? And then here we have some manipulation here. Let's set C divided by 1 plus R, the first term here, as A, and then 1 over 1 plus R as X. Okay? And then we can rewrite the equation this way. This is A times 1 plus X squared, and so on, right? So if we multiply both sides by X, then we have PVX equals A times the whole thing, right? And subtracting 2 from 1 gives us this equation, or this equation, okay? So by multiplying both sides by 1 plus R, we end up with this. And this is the equation you're going to see in chapter 6, okay? So in chapter 6, you're going to find out that present value of a console or a perpetuity is simply C divided by R. So if the payment is $10 per period, R is the interest rate or discount rate. I told you last class. It should be the market interest rate or opportunity cost of your money, right? So if the interest rate happens to be 5%, right, then it's a $10 divided by 0.05, okay? And it's going to be what? Something like 2,000 if you divide that, right? Something like, is that 200 or 2,000? Yeah. So that's how you calculate the present value of a perpetuity. Okay? All right. And then we do one more step. In order to understand the formula for the present value of annuity, let's think about this annuity here, right? We have a series of cash payments. And for how many periods, it doesn't matter how many periods, right? But let's say there is a series of $1 payments. And so that's a perpetuity, okay? And then we just learned that the present value of perpetuity is cash divided by R, right? So the present value is 1 divided by R. That's the present value of this perpetuity, right? And then think about another perpetuity here, okay? But the difference here is it starts 3 years later. It doesn't start today, but it starts 3 years later, okay? So what will be the value of this perpetuity, which starts exactly the same as the first one, but the only difference is this starts right now, this starts 3 years later, okay? What's the present value of this perpetuity B? Well, you have to just discount this for 3 years because you have to wait 3 years to start getting the payments, right? So it is the idea of deferred annuity. So here we have starting from third year, at the end of third year, we have these equal payments. Okay? Then what we can do is we can calculate the present value of this annuity. And then once you calculate the present value of annuity, you can discount the whole thing for 3 years. Okay? That's what we are doing here. Okay? So it is 1 over, according to the value, the present value of perpetuity, we know the value of this first annuity is 1 divided R, 1 over R at this point, right? So we divide it, multiply it by 1 over 1 plus R cubed, okay? Yeah. So we discounted this by 3 more years, okay? All right? So then we are ready to challenge the value of annuity. These two are perpetuities, okay? And suppose we have annuity which has cash payment of $1 for every period for 3 periods, okay? So that will be the difference, actually, between the perpetuity A and perpetuity B. In other words, if you subtract this from this, then that should be the value of this limited or finite payment which qualifies as annuity. Remember, in order to qualify as an annuity, you have to have finite periods. Okay? Perpetuity is not considered an annuity because it's unlimited, it's infinite. Okay? All right, so from that, we come up with this this formula. Present value of 3-year annuity, this one, is present value of perpetuity A minus present value of perpetuity B, okay? And with some manipulation, we come up with this. Well, you don't have to do that, okay? What did you say? All right, that's the same formula, okay? So if you look at the next slide, remember this was the present value of the annuity, okay? And in order to find the future value of annuity, we have to do this, right? So if you wait for T periods at the interest rate of R, right? So we're calculating the future value of this amount, okay? That's how we came up with this formula. 1 plus R to the power of T minus 1 over R, okay? That's how this formula has been obtained. The only difference is that we use I here in our textbook for interest rate and N for the number of years instead of T. Okay? So, if you were wondering, how this formula came around, you can go through this process and make sure you understand. Okay? All right, present value of ordinary annuity, we just looked at right here. This one was obtained as a present value of ordinary annuity, and that's the same thing as this formula. If you are in any doubt, why don't you work on it on a paper? Okay? So if you divide the whole thing by I, or if you multiply the whole thing by I, right, then you're going to come up with exactly the same formula here. Instead of R, you have to use I. And instead of T, you use N in our textbook. Okay? So any question about how this formula has been obtained? Okay. So the present value is a similar concept. This time, instead of future value, we are trying to come up with the present value. Okay. So ordinary annuity means cash flows occur at the end of each period. So let's say we have 5-year annuity here, 5-period annuity, and you discount all the cash flows, and if you add them up, that's going to be the present value of annuity. Okay? Again, you can use the table. Table 4 gives you PBIFA, which is this formula. Okay? So if you find the corresponding interest rate across the table and come down to the correct number of years or number of periods, then apparently here what we have is 5 periods and interest rate of 6%, right? PBIFA is 4.212. 4.212. So you multiply 1,000 PMT, 1,000 by 4.212, and you come up with $4,212. Okay? So notice that, well, 4,212 is smaller than 5,000, right? The point is here, you are making 1,000 payment for 5 times. So total, you made $5,000 payment, right? But the present value is less than that, right? Why? Make sure you understand why the present value of annuity is smaller than the total amount of payments you made, right? Because, again, the time value of money, right? $1 today is worth more than $1 tomorrow, right? So the story is, these 1,000 payments occur in the future, right? So future payments are worth less than actual $1,000 today. Today's payment of $1,000. So all the payments are discounted, right? So that makes the total value smaller than, it's just like if you, suppose you bought a car today and borrowed $212, right? And then suppose you promised the bank to pay off in 5 years, just once a year for 5 years, right? Then you have to make $1,000 payment for 5 times. The total payment is $5,000, much larger than what you have borrowed, okay? Because there is interest payment, okay? Any questions so far? All right, so this is the third session of Chapter 5, which is time value of money. And last class we talked about the annuities, okay? And I believe I explained how the formulas for annuity, future value and present value, have been obtained or arrived. Okay. So today, what we're going to talk about is, well, first topic is annuity due. What's the annuity due? What's the difference between annuity, just ordinary annuity and annuity due? Changhyun, help me. What's the difference between ordinary annuity and annuity due? It's a very simple difference, right? Okay, right. Whether the payment is made at the beginning of the session or period or end of the period. Okay? So which one is which? Annuity due means in the beginning, right? So if just like here, right? You have 0, which is today, and 1, 2, 3. That may be a year, I guess. The end of first year, second year, third year. Okay. But the ordinary annuity means you make the payment at the end of each period, here, there, and there, right? And that means the first payment would earn the interest for 2 years. Second payment earn the interest for 1 year. The last payment does not earn any interest. Okay? Annuity due, on the other hand, earns interest from the beginning, right? So the first payment, $1,000 here, earns the interest for 3 years. Okay? And the second payment earns the interest for 2 years, and the last payment for 1 year. Okay? So if you look at the formula here, there is no separate formula, but this is the future value of annuity, which is ordinary annuity, okay? Which is payment times FBIFA. And then now we multiply it by 1 plus I, which means we calculate the future value of ordinary annuity for 1 more year, right? Because just like I explained right now, we have 3 payments, right? But 1 payment earns interest for 1 more year compared to the ordinary annuity, right? In the ordinary annuity, the last payment does not earn interest, okay? But in the the annuity due, right, you earn a little more interest, okay? So the future value should be a little bit larger than the ordinary annuity case, okay? Does it make sense? Okay? If you're talking about present value of an annuity due, we can think about the same idea, okay? So let's say we have 5-year annuity due, okay? But again, the first payment starts right now, today, right? Period 0, okay? So when you're talking about present value, you are discounting future payment, right? So compared to the ordinary annuity, let's say, if it were an ordinary annuity, right, then the payments would have been made here, 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 and here at the end of each period, right? Right? So first payment would have been discounted for 1 year. Second payment would have been discounted for 2 years, and 3 years, 4 years, and 5 years. Okay? So when you add them up, you would come up with the present value of annuity. Okay? I turned this on, right? Just make sure. Okay. All right. But if you compare that to this annuity due, the 1 payment, the first payment is not discounted, undiscounted, right? So obviously, when you add them up, discounting means the value is smaller, right? So the total present value of annuity due would be what? Greater than or smaller than present value of ordinary annuity? I knew you would say that. Again, pay attention here, right? When you're talking about present value, right, we're discounting future values, right? So present value is smaller than future value. If it were ordinary annuity like this, then all 5 payments are discounted, starting from the first payment, okay? And when you add them up, it's going to be the total present value of annuity. But in the case of annuity due, the first payment is not going to be discounted. That's undiscounted, right? So that makes the total discounted value of annuity due greater than or smaller than? Greater than. Okay, good. So that's why we have, again, here, we just multiply the regular formula of PV annuity, present value of annuity, right? And we multiply it by 1 plus I. because one more payment, well here, this payment is undiscounted. Okay? So compared to the ordinary annuity, the present value of annuity due will be larger. Okay? Make sure you understand that idea. Okay. Now we're bringing in a few additional cases. Okay? The first one here is deferred annuity. Deferred annuity simply means it's an annuity, but it doesn't start immediately as of today, but it starts, say, 4 years later, right? So instead of 0, year 4 here, that's the starting point, right? So this is, in that case, this is annuity, ordinary annuity. So first payment is made at the end of year 5, well, this period, 5th year, and so on, right? So this is end of 5th year, end of 6th year, and end of 8th year, and so on, right? All right, so how do you calculate the value or present value, today's value of deferred annuity, right? What you need to do is just use the regular ordinary annuity formula, right? And calculate the present value of regular ordinary annuity, right? But then that answer, the one you calculate, would be the present value at this point, as of end of 4th year. Do you understand what I mean? No? Okay. We're talking about, let's say we have 4-year annuity, right? And here the payment is $15,000, okay? So someone asks, okay, here's an annuity. Annuity means a series of payments, right? So you can expect $15,000 payment for 4 years, okay? Just like regular annuity. But instead of starting it today, it starts 4 years later, right? So starting point is not 0, but here, at the end of 4th year. So your first payment is actually 5th year, 5 years later. At the end of 5th year, that's the first payment, 6th, and so on, right? So there's going to be a payment for $15,000, 4 payments, right? But what's the present value of that series of cash flows as of today? How do you calculate that, right? You have to do 2 steps. The first step is you have to calculate the present value of annuity at this point. So calculate the total present value of annuity, right? But that's as of the period number 4, right? And then you have to discount it for 4 years. Calculate the present value of annuity 0. Okay? So that's 2 steps. First step is calculating the present value of annuity at this point using the regular formula. Yeah? And then whatever comes out here, according to this calculator, the value comes out to be $40,555, $45,555, $555. Okay. Then our story is this: somebody promises to pay you $45,555 4 years later from now. Okay. What is the current value or present value of that one single cash flow, right? You know how to do that. Yeah? You know, you just discount it. So you multiply this future value times PVIF, interest rate and period, number of periods, right? And you can discount it that way. And according to the calculation, it comes out to be $28,973, right? Is that 28,000? I think I gave you some homework problems here last class, right? And in order to do that, I think you had to use this concept, right? Deferred annuity. So there is no special, difference. This is not entirely a new idea. We're talking about exactly the same annuity idea, but a few years later, deferred, okay, for a few years. Okay? Question? Is it okay? All right. And then we can also think about uneven cash flow, which is not an annuity. You know, in order to qualify as an annuity, you have to have a series of equal payments, right? Series of finite equal payments, right? So in order to use the annuity formula, you have to have the same payments every period, right? But sometimes you have different payments in different periods, right? Then you have to use this plain vanilla discounting formula, okay? So whatever you're going to receive at the end of first year, you have to discount it for 1 year. Whatever you receive at the end of 2 years, you're going to discount it for 2 years, okay? It's like when I use the down arrow, it's actually payments. You are making a payment, right? But let's say you expect $2,000 at the end of fifth year, $3,000 at the end of sixth year, $4,500 at the end of seventh year, and $7,000 at the end of eighth year, right? Then how can we calculate the present value of this cash stream, right? Well, in this case, you can simply discount it for 5 years, 6 years, 7 years, right? So the first present value is going to be 2,000 divided by 1 plus I for 5 years. Okay? I'm giving you a completely different example here. Completely different example from this one. Okay? The story here is you expect a payment at the end of first year, second year, third year, fourth year, right? But suppose your first payment will be at the end of fifth year, right? Then you can discount it for 5 years like this. And this value would be 3,000 divided by 1 plus I to the power of 6, and so on, right? So you have to just calculate it that way. There is no easy way, right? If you have uneven cash flow, okay? Any question? All right. Then, using the concepts that we already discussed so far, we can talk about a few practical cases, examples. Okay? Sinking fund. This is a topic of next chapter, actually. Next chapter, chapter 6, is about bond. Okay? And at that time, you will learn about sinking fund. Okay, bond, again, I think I gave you the rough idea of bond. It's an IOU. Okay? When company needs money, company issues bonds. Okay? They sell the bond and use that proceed to finance a project. Okay? And of course, when you issue an IOU, you have to make a promise. Right? When are you going to pay back the principal? Right? And until then, how many times, how often, and what kind of interest payments you're going to make, and so on. Right? And one of the conditions may be when a company issues bonds, they usually go through investment banking company, investment banker, right? And the investment banker is playing a role, go between the borrower and the lender, and lenders are, of course, investors, okay? And sometimes lenders require sinking fund, okay? The idea of sinking fund is, okay, the company promises to pay back the principal in 20 years, okay? But how do you know whether the company is going to have enough money 20 years later to pay back the principal, right? So in order to ensure that the company is going to have enough money, right, at the maturity, right? Sometimes the investors require companies to set aside a certain amount every year. So it's kind of savings account. Okay? So the companies are required to set aside certain amount every year so that at the end of 20th year, they're going to have enough money to pay back what they have borrowed. Okay? That's the idea of sinking fund. Right? So sinking fund means the future value is known. The question is, let's say a company has borrowed, say, $200 million, okay? And they issued a 20-year bond. Okay? So at the end of 20 years, they're going to have certain amount of money, okay? Future value. And let's say that's $200 million. Okay? The question is, in order to have $200 million 20 years later, how much money do we need to set aside every period? That's the idea of the sinking fund concept, right? So you know how to calculate it. That's future value of annuity is payment times FVIFA. Okay? And let's say current market interest rate is 8%. Okay? And it's 8% 20 years. Okay? So we know this value, that's $200 million. And this you can find from the table. Okay? So you can calculate this, right? Payment here. That's how this formula came around. Okay? Payment is future value of annuity divided by FVIFA from this relationship. Okay? So this is the case where you know the future value. You're trying to find out the payment. And you can think of many similar examples, right? I'm sure you can come up with some examples, where you know the future value. Let's say you are saving for your retirement, okay? And you intend to retire 30 years later, okay? And 30 years later, by the time you retire, you'd like to have at least $20 million saved, okay? Then how much money do you need to put into this account every month, right? You can calculate it that way, okay? Well, of course, if you use a calculator, it's a lot easier, right? In order to calculate payment, you're going to put in the future value, and you're going to put in the number of period and the interest rate, right? And then probably you need to set the present value as 0. Okay? So out of the 5 components, number of period, interest rate, payment, present value, future value, you provide 4 of them, right? You provide the future value, interest rate, the number of period, and present value. Set the present value as 0 if you start from 0 today, okay? And then solve for payment. And the calculator will give you exact number quickly, right? Well, just in case you forgot, let me show you. Where is it? Here we go. Okay, so here's the calculator. Apparently, we use this calculator on this computer, so it remembers the last number. So what do you need to do? You need to clear the register first. Okay, so click orange key and click here, All right, so you cleared all the register. Okay, and let's say you're trying to solve this problem. Suppose you need $200 million 20 years later, right? So 200 million, $200 million future value, okay? And 0 for present value. And number of years 20. And let's say interest rate is 8%. Okay? And just solve for the payment. All right? So that means each year they need to set aside $4,370,441.76. Okay? Every year. Okay? That's the idea of sinking fund. Okay? The opposite case is payments on a loan. Okay? Suppose you are borrowing money to buy a car or buy a house, whatever, today, right? So in this case, you know the present value. And you know the future value as well, right? Let's say you're buying $30,000 car today, right? And you're trying to obtain 4-year loan, 48 months monthly loan, okay? And how would you set up this? Right? So in that case, you know the present value. Present value is 30,000. It's a cash inflow because you are borrowing. The money is coming into your pocket, right? And then every month you have to pay back, right? So let's say you're trying to obtain 48-month loan, right? 4-year loan, right? And let's say interest rate. Let's say you have a terrible credit. Okay? You just graduated and you don't even have a job, let's say. Right? Sorry, it's depressing. Huh? So annual interest rate is 12%. Okay? Then how would you solve this problem? Well, we know the present value of annuity, and that's the payment times PBIFA. And PBIFA for what? 12%, 4 years? What PBIFA should you find if you use table? Are you going to use 12% and 4 years? Okay, yeah. Because what we are looking for is a monthly payment, right? Monthly payment. So you have to use 48 months, right? Then what's the interest rate? 1%, right? Because 12% is the annual interest rate. You have to divide it by number of months per year, right? So you can use PBIFA 1%, 48 months, right? And then, well, this is $30,000. Okay, so PMT will be whatever $30,000 divided by PBIFA 148, right? You find, okay? Or if you use calculator, you can clear the register and go 30,000 present value, okay? And well, it's easy to calculate because I said 12%, right? But in case it is 8%, suppose you have a better credit, and suppose your annual interest rate is 8%, right? Then what should you do is press 8, enter, 12, divide. So that means monthly interest rate is 0.67%. right? Instead of 8%. And you set that as interest rate, okay? And then the 48 months as the number of periods, okay? And then you have to set future value as 0, right? Because by the end of 48 months, you want the payments, the balance to be 0, right? Your loan balance to be 0, right? So you have to set 0 for future value, right? And then click on PMT. Yeah, $732. You have to make $732.39 payment every month. So I guess $30,000 car is out of range, out of question. Because your monthly payment, monthly salary maybe only $1,500. Right? Okay. That's how my children are working and living these days. All right. All right. Then the last concept here in this slide is present value of perpetuity. But this is what we talked about already last class. Right? What is the perpetuity? What did you say? Oh, no maturity, right? So it's a series of payment which lasts forever, right? So if it's a bond, you never pay back the principal. You just keep paying interest forever, right? Another example is preferred stock. Again, this is a chapter 7, the topic of chapter 7 when we discuss stocks, right? There's ordinary common stock and preferred stock, okay? On common stock, the companies are not required to make any dividend every period, right? But on preferred stock, companies are required to make dividend every period, okay? So it's just like a bond. When you borrow money through bond, company must make interest payment every period, usually every 6 months, right? But in preferred stock, there's dividend payment every period. So if you are holding a preferred stock of AT&T or whatever, right? Any company, right? What's the value of your preferred stock? You can calculate present value of preferred stock, okay? Then or PS. Okay? That's simply your dividend payment divided by interest rate. Okay? In one of the previous slides, I showed you how this payment, this formula came around. At that time, the formula was C over R, right? The cash flow divided by interest rate. The same thing as D over I, right? Dividend payment over interest payment. Or in case of coupon or bond, right? What's the present value of bond? That's coupon payment divided by I, right? If it's a console, right? In other words, if the company never pays back the principal, if it's only interest payments are made forever, okay? Okay, so that's the idea of perpetuity. All right. And then we talked about the compounding period of effective interest rate. Last class, I already discussed this. I already told you. Even if you're talking about the same annual interest rate, right? Depending on the compounding period, how frequently the interest rate is compounded, right? The total payment is different, right? So even if you borrow, that's first thing young people experience when you graduate college and get a job and you buy your first car, Okay? And that's a big deal, right? You have to sign the agreement and loan guarantee and all kinds of things. Okay? And usually the papers are about this thick and this long. Okay? And they say APR is 12%. Okay? APR is annual percentage rate. Annual percentage rate is 12%, right? Well, that's okay, but you have to actually read more, the fine prints, right? And then sometimes they say annual percentage yield or effective APR is something like 12.8% or 13.1%, right? Effective. So they use these different terms, APR versus effective APR or annual percentage yield, right? What happens is, well, even if you use the same annual interest rate of 12%, the question is how often do you compound? Do you compound monthly or daily or continuously, right? Depending on how often they compound the interest, right? The total interest payment increases, right? So here's an example. We're talking about the same $1,000 initial amount or principal, right? And we're talking about 10% interest rate. I guess that's annual interest rate, right? 10% annual interest rate. If you compound just once, in other words, if you compound yearly, then the total payment is $1,100, or total value is $1,100 because 10% interest is added to $1,000 principal just once, right? But sometimes they do semi-annually, every 6 months, right? And that means they're going to divide 10% by 2, right? So use the 5% interest and use that compounding formula every 6 months, so twice a year, right? Then the total value increases slightly, $1,102.50. If you do it quarterly, becomes a little higher, monthly, even higher, daily, a lot higher, and continuously, right? Sometimes they do it continuously. Well, I'm not quite sure any example of continuous. I think I told you the credit card companies usually use daily compounding, right? So if they say your annual interest rate is 18%, right? They divide it by 365, okay? And use that interest rate to compound every day, 365 times a year, right? To increase their revenue there, which means your interest payment is increasing, okay? So now you know the more frequent the compounding is, the greater the future value, right? You can think about the opposite case. Instead of future value, you can think about the present value. Actually, that's the next table, table 5.7, uses the cases of discounting instead of compounding, right? And there you can see that the more frequent the compounding, the smaller the present value, right? Because in other words, the effective discount rate becomes larger, okay? All right. So based on this, here's a formula to calculate the effective rate calculation, right? If you know the nominal interest rate, somebody, you're trying to buy a car, and the salesman tells you, well, we're going to charge you 12% annual interest rate, right? Then based on that, if you know the compounding frequency, M is the compounding frequency, right? So if it's a quarterly compounding, it's going to be 4. If it's monthly compounding, M is going to be 12, okay? So based on the nominal interest rate and compounding frequency, you can calculate effective interest rate. using this formula, right? So here's an example. If the annual nominal interest rate is 8%, but it's quarterly compounding, right? Then effective interest rate is 8.24%. Okay? You should be able to calculate it that way. If you point that out to your salesperson, he will be impressed. And he may not be able to deceive you anymore. I hate dealing with car salespeople. That's just exhausting. It takes all day. All right, net present value rule. This is just the last comment, because you probably know that already. That's a first rule in investment. Okay? When you have some alternatives, projects A, B, C, D, yeah, you have possible alternative investment projects, right? And what project should you undertake, right? The most the most popular rule is net present value rule, NPV rule. Okay? And that is, well, what present value do you expect from this investment? Let's say if you invest in this project, you can expect to reap the benefit for the next 10 years. Okay? And the first year may not be that great, maybe even negative $22 million. Okay? It costs money in the first year. Okay? But starting from the second year, let's say you expect 4 million, 7 million, 10 million. And usually at the end towards the end of the project life, it diminishes 3 million and 1 and so on. Okay? So you have to discount all these values and calculate the present value of the project. Okay? And from that present value, you have to subtract initial outlay. Usually you just use I0 or IO0, right? Because most of the projects require initial investment, right? So IO0. So net present value is present value minus I0. Okay? Well, then you are comparing an apple to apple, right? Because you expect all this future cash stream, but that's the future dollar, not today's dollar, right? So you cannot directly subtract today's dollar from future dollars. You have to first discount future dollars into today's dollar by using the discounting formula, okay? And then you're comparing the present value to initial investment, see which one is greater. Okay? If the present value is greater than IO0, then it's going to be positive, right? If it's otherwise, if the present value is less than initial investment, it's going to be negative, right? If it's positive, that means your project A will increase the value of your company. In other words, you are bringing in some cash, okay, for your company. If it's negative, then the investment project is not worth. Okay? That's the simple rule of net present value. Any question?